Hi everyone. Today we are going to talk about Scroll. Scroll is a thin C++ layer built on top of Orcs, which bring some interesting object-oriented features to Orcs itself. Um, there used to be two components. Orcs has been around for over 20 years now, but Scroll was developed 12 years ago, mostly when I was working on a game jam back in 2009. And I wanted to add like some extra tooling on top of Orcs, and that's where Scroll came from. And one of the feature back then was to create a level editor. So inside Scroll, there is a level editor called Scrolled, and it had maybe not as many features as you can see in more recent editor like Tiled or LDTK, but it still was interesting in the sense that there was like serialization. You could play your game inside the editor. You could like place object, of course, or group of objects, scale them, rotate them, align them on a grid, all those kind of things, having different layers as well. But I have to admit that over the last 13 years, I have not maintained the editor part much, which means that I'm not going to showcase it today. I do not even know if it's still in working state. Um, and I do plan to redesign the entire editor and make it more than just a level editor and being like an integrated development environment where we would be able to edit everything, not just the level itself. However, that being said, there are still functions inside Scroll that are heavily geared toward level editing and loading the maps. I'm just going to ignore those today, but we will see that when we come to the code itself. And the second component was to be able to bind C++ classes, so like the logic for your object, to config sections. So the idea is so that when you create an Orcs object, you can find a way to semi-automatically bind a C++ class so that it would be instantiated every time you get an object. Like for example, if you want to put all your NPC or your character logic in code in C++, every time you create an object that would inherit from the section of that character, the code would be instantiated and you would receive like all the events would be encapsulated into virtual methods like on create, on delete, on new anim, on collide, on separate, and things like this, making it much easier to handle events because you don't have to register listeners and you just have the events for your specific object. In order to work like this, in order to add this feature to Orcs, Scroll is simply using the custom data pointer inside the Orcs object, which means that if you use Scroll for an object, you cannot use at the same time the custom data pointer because it's been used by Scroll, and Scroll expects you to just use Scroll for this instead. So let's start a new project. And same as usual, we're going to just use init. We're going to call it scroll demo. And actually, let's see what kind of options we have. We can see that scroll is a C++ convenience layer with config object binding, and by default it's not active, and it will trigger C++. Meaning that if you're going to develop a project with scroll, your project will be compiled with C++ because scroll is C++ code. So if I were to say, okay, I want scroll, but I do not want C++, then you get a warning because you see that scroll triggers C++ and aborting the following extension have been both required and prohibited C++. So the unit script doesn't know what you want to do because scroll requires C++ and you told him explicitly that you do not want C++. But if we remove this and we just start with scroll, you see that a new project has been created and with all the project files. So now we're going to simply load our scroll demo inside Visual Studio. And there we go. Let me move it here. Hopefully you should see it. And let's see if we can build it in debug. I don't know where I build profile, doesn't matter, and release. And as usual, we are just going to do our little stream-friendly modifications. and by that I mean that we do not want it to be full screen. Let me actually zoom so we can actually read what I'm typing. Like 200 usually works well. We do want to be in, oops, in 1080p. And we are on my second monitor here. So if I start it, there we go. And I'm glad to see that this time there's no delay. I'm not sure what happened last live session. Windows is a mystery sometimes. So we do have our skeleton here. We are just going to keep the sound object just to make sure that my headset doesn't turn off like it did a few sessions ago. We are just going to make sure that it's not going to be too loud for you guys. And that's it. So right now, they're just the little chimes and an empty window. So what we want to do is we're going to go to scroll demo. We're going to add some data, and we're going to use some that we used in the past. Let me actually find it here. There we go. And we're going to take the king and pigs. There. Sprites mean that we want this pass on our resource. If you do not know how resource work inside Arc, please check the previous live session, the number 5, because it's all about resources and handling resources. So right now we're just going to add this path here, texture, and we have access to our resources. And we're going to create like a very simple object. We're going to create a bomb. And that bomb object is going to like have center pivot, it's going to have a animation set, which is going to be itself, and the stop animation is going to be idle. We're not going to use any user animation. We do need to have a key duration. Oops, I am not typing correctly today. We're going to play at 10 Hz, and the frame size, we're going to have to look at the texture itself. So here, if we look at the bomb, that's 09 bomb, and we're going to use this one here. So frame size is 5256. 5256. And we have our idle, it's going to be texture, and it's on 09 bomb, I believe. 09 bomb, there we go. That should be it, 09 bomb, okay. And we're just going to add it to our scene. Let's see if I did that correctly. Yes, we do have a bomb. It's a bit tiny, so let's scale everything up on the scene by like 4. There we go. So we do have a bomb. It's a Nox object. There is no logic attached to it. So if we wanted to bind like logic in code in C++ with Arcs, we would have to handle it ourselves, use the user data pointer and store whatever we want there and retrieve it. And that's the gap that scroll is going to fill. So let's have a quick look at scroll. When we create the project here, you can see there are 2 folders. One is called include scroll, and there are 4 files there, and then the inline one. So scroll is a project that will be compiled along your game. There is no pre-compiled thing, so it's make it very easy to port to different platforms that are supported by Arcs. All you have to do is have the files inside your solution, and they will be compiled along Arcs. So let's have a quick look. We're going to ignore the scroll head. This is the editor itself. Again, it might still be working, might not be working. It hasn't been maintained for like a decade or so. So it wasn't much code, like 3,000 lines, but the issue and why it's not maintained, it's because a lot of features that were added at the scroll level and the scroll editor level back in 2009 have now been moved to Arcs, and more often than not into like slightly different forms. So it's a bit redundant right now. So there need to be like a cleaner path of scroll itself, remove all the redundancy, and make sure that we work with modern orgs. It's something that I have on my to-do list, but right now it's not my focus. I'd rather like work on more central core feature on orgs itself than working on scroll, because scroll is usable. I just don't use it for a level editor. But there are level editors out there that already have like exporters for orgs, like Tiled, and I do plan to make one for LDTK, because LDTK is an excellent editor. So yeah, that will come at some point in the future. There is a scroll base, which is like the wrapping of orgs inside scroll itself. You don't have to look at that code ever. It's really like internal of scroll. And the last one, this one is not the last one, but former to last, this one is relevant to you because it's your game class. It's a scroll class, and this one will define a bunch of functions. So let's ignore everything that's map right now because it's to work with the editor. So we can execute the game. It's a simple function. We can create and delete objects. You can have a bunch of virtual methods. So like you can be notified when an object has been created or deleted. There's a bunch of notifications for map. You can be notified when the game starts or stops, because it's part of the logic of scroll itself. Starting and stopping. It's mostly used in the editor part, because when you were in the editor, you could start scroll and stop scroll. And then you can also pause the game, which is a feature that Orcs does not really encapsulate at a generic level, more at the object level, but Scroll makes it like at the game level, and we will see how it works a bit later on. Then you have like encapsulation for the encryption key for your config if you want to use the one that is different than the one that ships with Orcs, and the bootstrap function for your config needs. And you can see there's an update function. There's also a camera update, where if you want to have like camera-specific logic, this function will be called once all the objects have been updated and all the physics have been updated. So you don't get like, the kind of jittery movement you can see in some games when the camera is parented, like to or following an object that is moved by like physics, something like this. Sometimes you can see jitter in those games. This is to prevent that. The camera update will always come after all the objects have been updated. That's why it's a separate function in Scroll. And the last interface that's very important is a scroll object one. This is what you're going to use most of the time, and this is what makes the strength of Scroll itself. It's basically a wrapper on object, and you can see that there are a bunch of functions that wraps orcs function as well, like enabling, getting the group, setting, getting position, size, and scale, the rotation, speed, the color, all these have been encapsulated. You can add shaders, sound, effects, you can add tracks, you can add conditional tracks. I will come back on this one later because it's a handy function. And you see there's a bunch of wrapped function. And you can extend it as well. If you want to add your own wrapper, go for it. And this is the part that's very interesting, that it will encapsulate a lot of events sent by Orcs, object events sent by Orcs, and we'll just have you implement a virtual method instead, which will make it very handy to easily handle things like collisions or like animation events or these kind of things without having to register an event, filtering for the kind of object you want. All this is done for you. So you can see we have like a traditional create, delete, update function. Those three are mandatory. If you do not define them, Scroll will tell you no, you need to define them, because really there's no point in creating a Scroll object derivative if you're not going to override like creation, deletion, and update. All the others after are like they are completely optional, and you can ignore them. And that's it. So now let's see how we use it. If you look at our little prototype here, we can see that our scroll demo increments scroll. So basically, it's just going to include scroll demo, which includes scroll itself here. You can see that there's defined that says no scroll head, so we don't want to build the editor. If we remove this define, the editor will be built, and you can actually start the editor from the same executable than your game by just providing -editor on the command line. But again, that feature is obsolete. At least it hasn't been maintained, so we are going to ignore it. So coming back to here, we can see that we have like an update function like we would have with a regular orcs. We have the init function that display a bunch of things and create the object scene. And we have like a run, exit, bind object. We'll come back later because this is very important. The bootstrap one, where we had like the storage for the config, and we tell Orcs if we want or not to load the default config file. And you can see that it's a single line for executing scroll as well, like we did with Orcs, except this time you just retrieve the instance of your singleton for your game class, and you call execute and pass the main argument to it. And that's it. So we're just going to clean a bit this kind of thing. Like we're just going to remove some spam. We just want to create a scene, and that's all that was done for us. Here we can see that there is a function that's actually a virtual method called bind object, and that's where we're going to do the binding of C++ classes to config sections. And here we see that we have an object called object. That's a class object here. Yeah, I know that's not very imaginative. I could have called probably better, but here you go. We have an object, and this object is deriving from the scroll object. Actually, I didn't show the scroll demo, but you can see that scroll demo inherits from scroll, and it's the recursive template so that we can use it like to instantiate the instant and things like this. And here we just define like the init, run, exit. This function, we're actually not putting anything in it, so we could have removed them. The important one is the update one. It's the one that you usually register with the core clock in Orcs. Here you just implement the virtual function. And same thing for the bind object. That's a virtual function that's going to be called automatically for you. Here we have the class object that inherits from the scroll object. And you can see that we're just overriding on create, on delete, and update. And by default, the skeleton doesn't do much. It will just write a Boolean called, the property is called isObject, and you set it to true. And inside the onCreate function, we're going to be in the section, in the config section, named after the model of the object itself. So we don't have to do like push config section and pop config section, but that is an exception. It only happens for the onCreate. It's just because it's convenient and it's not more costly because the section was actually pushed before. But for the onDelete and update, if you want to go into specific config section, you will have to do it yourself manually. So this is a bit of like just a convenience method. Here you're already inside the config section of your object. So let's see how it works. Right now we only have an object that's bomb, and if we were to look at what's inside bomb, and oh, you know what? Let's make sure that you can read the console. I forgot to do this one. So scroll demo ini, and here we're just going to add render console font scale, and I believe 3 is a good size. There we go. So if we were to look inside the configuration bomb, if we are looking for isObject, you can see there's no value. It's because the bomb is not a scroll object, and we can actually even see that better by simply going into object and putting like breakpoints in the function, and you can see, oh, one object delete. Which one is it? That's definitely not a bomb. Call stack. Where's my watch? My watch is this. There we go, and that is not the bomb itself. Oops. Wow. If we go back to our, oops, why is it not working? There we go. If we go back here, we can see that bomb is just a config section. So when we create it here through the scene, it's just an Orcs object that's going to be created. However, if we were to create it differently, so instead of creating the scene here, oops, so here we only have the sound, we don't have a bomb. If we go back to the scroll demo and where we create the scene, if we were to create also the bomb like this, and we run, and you can see that the scale is different because it's not a part of it's not part of the scene anymore. Even if we create it through scroll, it still remains an Orcs object. You can see that the game bomb is object returns nothing, and the onCreate hasn't been called. This is a wrapper that will create either a scroll object or an aux object based on what has been registered. Here we only bound object class to the object name. But let's say here we also bind bomb to the object one. And if we create it now, it's going to be different. You can see that we break through the onCreate. And if we were to run his object, it says true. That means all the code here is going to be called for our bomb object. It's because here we say that the config section bomb has been bound to the object section. And that's good. Now, even if it was created through aux itself, through the child list we've seen earlier, it's still going to be a scroll object. As you can see here, it's because the binding that is made inside the bind object method works no matter how you create object. If the object is created through scroll, if the object is created through aux via code, if the object is created through like a country property like child list, every time if there's a binding, it's going to be honored, and you can be sure that if you bound a C++ class to a config section, it will always happen. And this is so that everything is consistent and you don't have like weird edge cases depending on how you create your object. Every time the object is created, no matter how you create it, you will get the same result. So that's fine. Now we have bomb, but let's say that we wanted like a different kind of bomb. We wanted like a large bomb, and the large bomb is basically the same thing, except that it's going to have like a larger scale. And here we create the large bomb. There we go. So it has a regular bomb and large bomb, and let's ask large bomb if it's an object. It says no, of course not, because there's no binding between large bomb and the object section. So we would have to write like a binding here. I say, oh, I also want large bomb to be bound to an object. And now you can see that if you run and if we ask large bomb if it's an object, it says true. So the C++ class has been added. This is very cumbersome. So every time you would have to create like a new type of object, you would need to bind it and modify the code and your executable, and that's not the way it works. Thankfully, Scroll will respect config section hierarchy, meaning that anything inheriting from those sections are going to be of the same type. So if anything inherits from object, it's going to be associated to the C++ object type. So let's remove those two bindings for bomb and not bomb, and you can see that now if I'm asking again, they are not objects anymore. All I have to do here is saying that they are object. And because object is bound to the C++ object class, they are back to having a scroll object running on them. And even better, because the large bomb basically is just a bomb with a scale of 2, you can just do this and just put the scale, not touch anything else, and you can see that it's still working, and it's still a scroll object. It's because the entire hierarchy is going to be honored. So like the large bomb inherits from bomb, which inherits from object, and we do have a binding for object, so this C++ class is going to be used. And this is very powerful because you can add any variation in config and still have your C++ class bound to these variations. So let's see what we can do a bit more with this. We're going to look at the scroll object interface, right? And we have a bunch of virtual function, and we have one that is called onAnimUpdate. Let's override onAnimUpdate for our object. So we're going to go to object. We're going to say that we want onAnimUpdate. And in object CPP, we're going to implement it. Okay, and we're just going to add a log. So we just want to log the model of the object. And because we're in release, we don't have the log, so let's go in debug. Here, if I bring the log on this monitor, you can see that what is being logged. Sorry, I said the model. It's the animation. It's the animation. So here, every time the animation is updated, we get notified. So that means every time there's a new frame or a new animation, we get notified through the OnAnim update. Let's try to do something a bit more interesting here. We're going to use the OnAnim event instead. So I'm going to change this one. There we go. And in the object, we're just going to overwrite this one too. And here we have much more information. So we want this time I will put the actual name of the object, and you can retrieve it with get model name, get model name. There we go. Get model name. Then we want the animation, the event, and the event let's put it like this: animation event, and the event is going to give you the value. And at time. So here we have the model name, we want the animation, the event, and after the event we said what we wanted the value, and last the time. Let's see if this works. You can see nothing happens. It's because we have no custom events right now on this animation. So let's add a custom event and see how it goes. So coming back here, we're going to actually remove the last one because I'm just going to pollute our log. We have here, we say, okay, idle one, I'm going to have a key event, and my key event is going to be my on event value, I don't know, 10.5. Okay, let's run this. And you can see now that every time we arrive at the first frame, we get the event my on event and this value, and the time is 0. It's indeed the first frame. If we were on the third frame, given that each frame is 0.1, the time would not be 0 anymore. It's actually 0.2. It's a third frame every time in the animation. So we have the relative time inside the animation of when the event has been fired. And this is fine because we can do a lot of handling with this. Let's try to do something a bit more, a bit smarter than that. Let's say that we want to do something with this event, but only if the event is called like move X, for example. So if our event is move X, we're going to retrieve the current position. So get position, and we're going to modify the X value, oops, with the actual value that has been sent through the event. And we're going to update our position with this. So right now, nothing happens because we don't have any move X events. Fair enough. Let's add some. Let's say that every idle 3, so third frame of the idle event, we are going to trigger a move X event of value 10. And let's run. Oh, and you can see that we are moving 10 pixels to the right every time this frame has been fired. And we could do like something a bit more like say that on the idle one we go back 10, and you can see that now when it's ticking, our bomb is going left and right every 2 frames. So moving an object is probably not the most interesting because we can actually do it inside like with a command. Remember that the key event of animation can also be commands. So if I were to change this and write like commands, like saying, I want to object get the current position of my object, and then I want to add to this position -10 on X, oops, on X, and then I want to set the position of my object with this, And if I don't make any typo, that should work. And let's see if it moves to the left. Sorry, I have this. Yeah, it does move to the left. Okay. There we go. And let's remove the log because, okay, we don't have log. Okay, perfect. And we're going to do the same thing here. And this time we want 10 to the right. And yeah, it works as before. But with it entirely in config, we don't need the C++ code, but it's a very specific example, and you can see that it's still a lot of commands. We have to ask for the value here, whereas if we wanted to have a system where characters move precisely at the pixel perfect position based on the animation, we could just use a key event that had pre-generated offline, and every time you export your animation, you would also export the value. That's actually something I'm doing in a project. So let's see if I can run it for you. This project here. There we go. That was an old prototype, like from 5 years ago. I was doing it with a friend. And you can see that when moving, it doesn't look like it's sliding or anything. It's, I don't remember the control. There we go. Even when it runs or slides, it's always pixel perfect, and it's actually using auto-generated animation events in data that are handled in a very similar way that I've shown with Scroll right now. It's just basically retrieving like a vector this time and not just a float. And it's moving accordingly the character based on this. And this is an entirely automated pipeline because the 2D animation you see right now, they're actually coming from 3D. And the 3D exports, I think it was from 3ds Max, but we work within the 3D modelization software. It would export me also like in an XML file the amount of movement for each frame, and I would have just like a small script retrieving all this information and writing them down inside a config file instead of having it like manually done like this. This was generated by my script, but the data would always match the animation for any objects, and then at the end you have like something that works like without any sliding or anything, and also allows like for acceleration and things like this without having you to handle it in code. Everything is handled through like it's data driven. It's a root motion as it's often called, but in 2D. So that's one way to do it, and you see it's very simple with the anim event function, and yeah. So for now, let's just remove those here, and let's see what else we can do with this. So if I did a mistake, the bomb should be back. Actually, I'm going to remove I'm going to back in release because otherwise I have the log popping on my screen and I cannot see what I'm doing. Okay, so we're back. We have our bomb and it's an object. Let's say that we want to create a new class, like a character class. So we're going to do this right now, and because I'm very lazy, we're just going to copy paste. So we go here, we're going to go to the source, so include, the object is going to become character, and the source. Of course, you can write it from scratch, just that, again, as I said, I'm lazy. And I'm just going to do it this way. And I'm going to regenerate the solution so that it appears in Visual Studio. And for this, all I have to do is not go too far, come back to the build, and just run pre-make. And you can see that now if I go back to Visual Studio, I hit reload, and I do have my character header and my character source. So we're just going to replace object by character. Oops, character. And we're going to replace all of them. And this one is particularly, I'm going to change like this, character H. I know that there are Pragma ones now, which should probably be used instead of this. But bear in mind this code base is quite old. So, and I would say that my character inherits from object. So I'm going to get from object.h. And we're just going to write stuff inside character, but we also want to keep like the object logic. So like, for example, what I have for the root motion inside the object, the character is going to inherit from it. So especially if I don't do this. This way I can like layer my different logic, like my object handle like the things that are common for any object, and my character is going to handle things like inputs. We're going to add inputs to the character. And then on top of the character, I can create like a branch from like to playable character and non-playable characters, and I add like actual like a way to bind to this input. So like one would bind to physical inputs and the other one would just bind the brain to these inputs. Let's try to do this in this session. So that's for the header, and if I go to, I have to open it because I have not opened it before. Here we're going to do the same thing, Control H, character, there we go. And so we have on create, we're going to say is character true, delete, update, we don't have this one. And because we're inheriting also from object, I also want to call the parent one, which is on create. This way it's going to be both an object and a character. So we do have like a new character class. We need to register it. You know, remember the bind object here? We're going to do the same thing for the character. We're just going to say, I bind my character class to the config section called character. And I probably need to include it as well, character. And now same thing here. If I say get bomb is object yes, is a character, nope. So let's create a character. We're going to go to our scroll demo, so at the bottom, and we're going to create a character. Let's name it Bob. So Bob is going to inherit from the character section. And the character section is empty right now. But if I create a Bob, and let's create a Bob here, even if we cannot see it, if I ask if Bob is a character, it says yes. And there is a Bob character. So if I log everyone, we should be able to see Bob. See, Bob an object, but there's nothing under. So let's give Bob a few traits on its own. So let's also say that characters inherit from objects. So the way it works, Bob is a character, character is an object, and which C++ class is going to be used? Well, the first one we find when we go up the hierarchy. So is Bob bound to something? No. We're going to check character. Is character bound to something? Yes, it's bound to the character class. So we're not going to check further up, and it's going to be an instance of the character and not an instance of object. So if you remember, we can use a prefix for the animation, and we're going to say that's the prefix. Oops, not here. Sorry. Come on. Here, Bob, and we're going to tell Bob the idle is a different texture, and the texture for Bob. So a few things actually. We're going to put something at the object level, like pivot is an object. Using an animation set is also coming from here. The start anim also going to be part of everyone for now. The key duration also. The only thing that we want specific to the bomb is the frame size, and for the idle it's the texture. Same thing here. So we are going to say that the frame size is, and we're going to check on the data because I don't remember by heart. So let's use data, texture, king and pig, sprites. Let's say Bob is a king human, and it's going to be the idle, which is 78 by 58. So the texture is 01 dash king human, and the frame size is 78 58. So if I did not mess up, I should have actually, let's move it a bit. Position for Bob is going to be slightly above. Yes, we do have Bob that plays an idle animation, and if we look what Bob is a character. So let's give Bob like a mean to walk. So Remember, we just have like the idle animation right now. Well, we're going to say that characters are actually going to do a bit more than that. So from the idle, we can loop on idle and we can immediately transition to walk. And from walk, we could either loop on walk or immediately transition to idle. And we're going to say that this is the highest priority. I mean that if we do not have a target animation, we're going to go back to idle. And that's all we want to do for the modification of the animation set for the character itself. So now we have to define our walk animation. And Bob walk, I believe it's called run, if I'm not mistaken. Yes. Okay, so now Bob should be able to run. Let's see, object, find Bob, object, set animation, and walk. There we go. The animation works well. But now we're going to trigger it in code. So every character is going to be able to do this. So let's just write a bit of code here. We're going to say that we get the current set, input set, args input get current set for backup for later, and we're going to push select set, and we're going to get the model of the object. There we go. And at the end, we're just going to restore our previous set, select set, and it's going to be the previous set. Okay, so in between those two calls, we're going to use the input set that is using the same name as the config section of our character. So here it's going to be Bob. And we're just going to, you know what, I'm just going to copy paste code so that it's going to be faster because it's exactly the same code we've been using in the past project. So let's just do this. Okay, so I'm going to copy this and put it here. So what do we have here? By default animation, we want nothing. We want to follow the flow. So arc null, we're getting a move vector, which is computed with the input values from move right, move left, move down, move up. And if we have a move, we're going to say the animation is going to be walk. We don't have a run right now. And we're not going to do all this weird stuff because we don't have like 8 directions like we used in the past. We're just going to multiply our move vector by a config value that we're going to call walk speed. And because of this, we need to push the config section, and we're going to pop the config section here. Okay, so we obviously need to define move speed for our character in data, and we're going to use the same for all the characters, and walk speed is going to be 100. There we go. So if we have inputs, we're going to trigger the animation walk. We're going to retrieve the walk speed, multiply our vector with that, pop, and apply it. And here for the animation, all we need to do is call the animation here. There. And here we actually go back to the previous set. So if we do this, we have like virtual inputs for moving characters. But let's say that we bind some inputs inside here for Bob. Let's say we want to use the keys, arrow keys. So key up would be move up, key down would be move down, key left would be move left, and key right would be move right. Let's see what happens. Ah, not moving. It's not moving because the input set hasn't been enabled. So if I were to enable it here, so like arc input enable set and of get model name. And if I do this, oops, what did I make here? Oops, forgot true. And if I were to do this, now I can move my character. And you can see it plays the move animations. But I do not want to bind physical inputs at the lower level of the character. I want to create a class that is called playable character that does this. So I'm going to create a new class. And again, I am still as lazy as before. So I'm just going to go from character and call it PC. And in includes, I'm also going to call it PC. And we're just going to go, oops, my bad. I lost my visuals here. I just want to go inside here and regenerate our solution, reloading, and now Command Visual Studio, we have a PC class. Yeah, this one is inheriting from character, and character is going to be PC, and it's inheriting from character. Okay, we're good for the PC, and here as well. H character PC. There we go. So we don't need all this update here, right? Because it's done at the base class level. All we need to do is call the base class update rst info. Okay, and here in the pc.h we want to include character. We are good here. We are good here as well. And the last thing we need to do is bind our PC. So PC class bound to PC section, and here we are going to include PC. There we go. And Bob can still not move because remember Bob was a character and not a PC in config section. So if we go back to our scroll demo here, and if we say that Bob now is not a character, it's actually a playable character, and we start it, and it's not working, so I guess I messed up something. Let's see what happened. Debug. Oops. Oh, right. Well, I know why it's not moving, but it should still be showing though. So why is it not showing? Oh, yes, I know why it's not showing. Okay, come on. There we go. It's not showing because I did create PC, but I didn't say that PC is a character. So all these and all the things that are in objects were not inside PC. So Bob wouldn't know that it actually had like an animation set and thing like that. So now he knows it. He's going to create the right class PC. And because in debug I have a log in front of my face, let's go back to release. Bob is back, but still not moving. And it's not moving because we didn't do our code in the playable character. Remember, all we want to do here is, actually it's not object, but character that we want to call here. And we want to enable our set, which makes physical inputs available. There's a live session on this. I don't remember. I think it was maybe the third live session. And you should go check like for physical versus virtual input inside Arcs. So enable set of get model name and Arcs true. And now if I do this, we have Bob that's walking again. And the good thing is that we can create more characters. So let's say that with our friend Bob, we also want John. And John is also a playable character. We are just going to change a few things here and the inputs. Actually, we're going to change all this. So let's put John below. Prefix is going to be John. The frame size, okay, let's see who we're going to use here. Data, texture, kings and pigs, sprites. We're going to use the king pig, and the king pig is 3828. So 38, 28, John. It's King Pig 3828. Actually, this is run, and that's John Walk. John Walk. Okay, and because I'm a bit lazy, I don't want to look for our scene. We're going to say that the child list is also going to have a John inside it. Let's see. We have John, and they are both bound on the same inputs, so we want to change this. So let's say that up is W, down is S, A, D. Oops. There. And now, oops. Visual Studio, why is there we go. Okay. So now we can move Bob with the arrow keys and John with the WASD. And it's super simple. As you can see, all we have to do is a specific inside the new character, and they are both coming from playable characters, so they are both going to inherit all the animation set, the graph itself from the character, the walk speed from the character. We could actually override the walk speed. Let's say that actually John is super fast and is going to move twice as fast as Bob. So Bob and John goes much faster, and we can actually like try to race them, and you can see that it's the case. So let's see a couple of more things. So before I go into like having an NPC class, because that's what's going to come next eventually, where we're going to add like a brain to characters, and we can see that if we want a character to be a PC or NPC, all we will have to do obviously is just inherit from the NPC class or the PC class. Actually, you know what? Let's just do it right now. This way it's done. Sorry, I'm doing that on the fly. It's not like it's been prepared. I'm winging it as we speak. So the PC, now we have NPC, and same thing for the source. The PC, we do have NPC. And we're just going to regenerate our solution. Yes, please. There we go. So NPC, obviously, NPC, oops. There we go. Is NPC. And NPC is going to be also a character. However, we don't want to do this, and here we're going to add brain here. And for the NPC here, see, there we go. So we have the NPCs inheriting from here, and in our base game here, we're just going to include npc.h. There we go, NPC. We're going to bind our NPC class. So the binding is something I would like to refactor at some point inside Orcs. I would like to have it like more data-driven. I haven't found the perfect way of doing this because of C++, but I think I have a couple of leads, and I would like to remove this part entirely and just being able to do it from config instead, and just being able to like register the classes here. And there are ways to try to automate it with C++, but they are not. I'm not sure they are entirely portable, so I'm still thinking about it. So that's something that might come in the future. Let's go back to the NPC class. We are good. So this time, let's not make the mistake and just say that we have a PC class, and we now also have an NPC section, and it's also a character. So if we were to say that John is an NPC and not a PC, and I run it, I can still move Bob. I cannot move John at all because it's not a PC anymore. If I were to put back John as a PC, you can see that it becomes playable again. So let's just add a brain. Let's add a very, very simple brain, just to make sure that it works. So we're going to copy paste some stuff here. We're just going to copy paste this because it would be too long to type. So let's go to the NPC code, which is here, and we're just going to have our brain here. And our brain, you will see, is super simple. We're going to have a timer. When the timer is expired, we're going to retrieve the timer value, and we're just going to do a similar thing as before. So like backing up the current set, selecting the current set. Here, because we push the config section, the same thing as we're calling get model name. It's interchangeable because we're inside the config section, and we're just going to push the buttons randomly. So move right, move left, move up, down. We don't have a run. We're just going to push them randomly, and then we're going to restart this, and we're going to do this every X time. So what we need to do is also like have like initial value for the timer, right? So we're going to put it here. There. And we of course need to add our timer value here. Oh, come on. Okay, it compiles. We just need to find a value for the timer to reset every time. And we're going to put it at the NPC level. Let me check what I used in the past just to see what we have here. Mix and match. Timer. Timer. What did you use for timer? I don't know. I'm just going to say every 2 seconds. Just like, why not? So, where is my visual? Here it is. Okay, so if we go back to the config here, we're going to say that on NPC, you see that basic timer is going to be 2 seconds or 1 second. Let's see how it works. And you can see that, hey, Bob has a life of its own and just pushing randomly. Okay, bye, Bob. But you can see that now, if I inherit Bob from NPC, it has the brain of the NPC, which is like definitely a very simple, dumb brain, but it just will illustrate our feature. And here, if I put it back in PC, it works again. And both, if both were like NPCs instead, and you can see that they are moved. So this is actually also very helpful for, obviously it's very powerful because I have one base class, and I can turn it into a player character and a non-player character at will with just changing a line. But it also allows you to debug like your NPCs. Let's say that you create a bunch of NPCs and you want to make sure that all your code, like the action, the attacks, all the interaction works well. Instead of writing logic, you can just bind it to like physical inputs. Like let's say that Bob and John are NPC by default, but I'm just going to create I could put that in a dev.ini file separate from here, but just for the demonstration, I'm going to say, I want to debug Bob, and instead of being a NPC, Bob now is player character, and you can see that I can move Bob, and he's doing what I want, and I could actually debug all the action by just slapping physical input on top of it and seeing that all the underlying code is working fine. And then when I'm done, I'll just remove this line. Visual Studio, my cursor, thank you. And Bob is now back at being a dumb NPC and living a life of its own. Bye, Bob. Okay, so hopefully you can see how this can be very, very powerful for developing advanced stuff with like no code modification and just like a slight data modification. And you can create as many variations as you want. Like I could create like Alex, who could be another character, and by just defining what is specific to Alex, like the prefix, the frame size, and the animation sheets, then I have a new character which is Alex, and I could override like the walk speed and any other properties I would decide to put in config. Let's do something a bit different now. So we have 3 objects. Fine. Let's check what we have inside scroll itself. And after that, I'm probably going to stop. But let's showcase pausing the game, because I think it's something that could be interesting for some people. So if we looked at the scroll H interface, and if we look for pause, you can see that we have a notification called on pause game. But there is actually also in the scroll base, there is also like a pause game function. So let's try to pause the game. So we're going to go to a scroll demo in the update function here. Where are you? If aux input has been activated, pause. Well, we're going to pause the game and unpause the game. Is game paused? It's a toggle. Every time the input is like pressed, we're going to pause and pause. So we just have to define this input. Going to scroll demo, we have our main inputs. We're going to say key space equals pause. And let's see what happens. I press space, everything pauses. All the objects, nothing is updated anymore. And we can actually check that by simply going to, let's say, the object CPP and the update function. We put a breakpoint. No, that's not. I'm not sure why it keeps doing this. It's because it's a release build. You know what? Let's do a debug build. It was puzzling at the beginning of the video, and it's definitely because it's a release build. Okay, so if I put a breakpoint here, you can see that I'm going to break, and let's remove the breakpoint for now. Let's pause the game. Let's go back here. The breakpoint is not hit anymore because the game is entirely paused. All the objects are paused. If I unpause, bam, we come back here. That's fine. It pauses everything. It will actually pause scroll object and aux object alike. Everything is going to be paused. But what if during your pause you want things to be continuing to live, like your menus, for example. You still want the object menu to react, have animation, suffix, sound, these kind of things. Maybe you want like some background animation and things like this. So you want things that are not paused by the game. And for this, you have like a couple of ways of doing this. So if we looked, actually, I don't even know if we can do it in code, but like, looked at this, we do have an on-pause game inside the scroll object function itself, and you can see it returns a boolean, meaning that you can try to override if you want to be paused or not in code. So every time the game is paused, it will send you, it will call that virtual method on pause game, and you can decide if you actually want to honor it or not, and pause yourself or not pause yourself. It's fair enough, but that's writing code. There's actually an easier way to do this. Let's say that we don't want our bomb to be paused, but everything else to pause. Don't ask me why, we just want this. So let's say that bomb here, there's a flag that is recognized only by scroll, it's called pausable. And now our bomb is not pausable anymore. Meaning that when we run it, and if I press space, the bomb is not paused and it keeps ticking. And it's on C++ code is also going to be ticked and continue like nothing happened. If I unpause, the other guys are coming back, but the bomb is totally unaffected. And we can also do that at the game level. If we look at the scroll interface, you can see that it has an on-pause game, and we can be notified when this happens to do like more advanced things as well. Like, I don't know, if you have treatment to do, like if the game is paused, it's a good time to, I don't know, update your leaderboard, save your data, so save your save game on whatever you want to do, you can do it through this notification. And I believe I covered, actually I didn't cover all of this, like create and delete objects, we can do it manually. And there's also a way to iterate over the object. And this is something that has been requested recently. And you can see there's a bunch of functions for picking object, for getting the next and previous object, or just for retrieving an object through its GUID. Scroll does wrap this at the scroll level. You can retrieve a scroll object through its GUID. You can even actually use like a template, and if it's the right kind, it's going to work. Otherwise, it's going to return null. And something for the next object. You can iterate over like all the objects inside scroll, or you can iterate over only a subtype of object. So like if I say get next object, the bracket NPCs, I will only go through the NPCs. Let's actually do something like this. Just for the demo, we're going to go back to scroll demo. And here, when we pause, what we're going to do also is for, let's call it auto object, object equal Scroll demo, so it's a get next object. We want all the NPCs, and we want the first one, while object get next object NPC. There we go. And we're just going to auxlog NPC, and we're going to do object get model name. So if we press pause, and you can see that nothing happens here because we have no NPCs. But now let's say that we do have an NPC. Let's go back to scroll demo, and let's say that John is an NPC and not an NPC anymore. And let's try to pause. And you can see we went over the John, which is our only NPC. However, if we were not going to use the templated version, which we'll remove the template, means that we're going to go through all the scroll objects. And here, let's call it scroll object. And let's pause. Whoops. Let's pause. And you can see we have the scene, the bomb, Bob, and John. They are all scroll objects. And so that's one way to iterate. And the pick function also work with like subclasses, as you can see it here. The pick also, the pick actually doesn't work with subclasses. It's any scroll object. However, you can pick like for position or boxes, and you can select the group. And it's just a get next, get previous, or the get object that can be subtemplated. Function, pausing the game we've seen. Another thing that's important to know is that if you don't have any class, but you do want them to be scroll objects, so that when you handle them, you know that for any arcs object, there will be a scroll object attached, which can be important, like in your code, if you don't want to check if the user data pointer inside the arc object is null or not. You can use the scroll object as the base class. So like if I say this, if I go here and I don't say that bomb is an object, let's say I copy all this inside bomb, and bomb is not an object anymore. So bomb is not an object anymore. Okay. Get bomb is object, not. And if I pause, you can see that we see that bomb is a scroll object. Why is it a scroll object? It should not have been a scroll object. Oh wait, how is it created? No, it's created. Oh, it's created through scene. Okay, I'm a bit puzzled by this one, but in any case, disregarding what happens here, if you want something to be associated with a scroll object, all you have to do is inherit from scroll object like this, and that will make sure that this object is going to be a vanilla scroll object, and it will have a scroll object attached to its arcs object. So this is important to know. That would have to debug to see exactly what's going on here, but it's not the purpose of this talk. And I already been speaking for like an hour and 10 minutes, so now is a good time if you have any questions. Well, no questions, no comments?
I had a question about the input handling. Do you think it'd be worth adding, you have the push section and pop section for config sections, the input set, like per object input set handling seems like a really straightforward and clean idiom to use. Do you think that would be a worthwhile addition, or is there...
As a scroll object, yeah, it could. It's just that this idiom for me was more recent than scroll itself. It's something actually I started doing like maybe a year ago or something like this. But yeah, definitely, I could definitely retrofit it inside the scroll itself. It's actually something I've been done with something I said that I would demonstrate earlier, and I did not. That there was a function called add track, and there's one called add conditional track. So we can just look at what the conditional track does. If you add a conditional track on an object, it's going to actually retrieve the config for this object, and it's going to look if there is a property with that name. And if it's found, then it will add the value as a track on the object. Meaning that if it's not defined, no track will be used. So it's very helpful, like if you want to say, like, let's say you have a projectile, and the projectile, when it explodes, you want to sometimes have like a sound, sometimes not have a sound, and you want to handle this with a track. In your code, you can say add conditional track when you collide, explosion, and Orcs is going to actually scroll is going to check inside your object if there is an explosion key. It's going to look at the value and use it as a track and add it, and you can do whatever you want. If there is no key, no track is going to be added there. So it's actually an idiom that has been used by me a lot, and I retrofitted it at the scroll object level. And as you can see, it only affects like the scroll object header. Everything is, the header and the inline, and it's just like a single function wrapper. So I could definitely do the same thing for the input. However, the current idiom of using the current model name, so that the config section, is probably not the best idiom. I mean that if you want to have two Johns right now, they would basically use the same input key, and I don't know if that's something we want or not. And it's also not the best maybe if you want like to remap input, like say you have John, but sometimes you want John to be player 1, sometimes you want it to be player 2, and these kind of things. I need to think more about it, but yeah, I think that would be a good idea to retrofit this kind of idiom inside the scroll object itself. Maybe instead of just being the config section as it is right now, so if you go back to like the character here, instead of being the get model name, it could be like a config value. So like it would be args config get string input, and all you have to do now is inside the scroll demo INI, instead of putting this here, you could have say, okay, this is P1 input, and player 1 input is this. And here I say, okay, John, you're not an NPC anymore, you're a PC, and your input is going to be player 1 input. And this could be easily changed on the fly at runtime, instead of trying to remap all the values there. So I'm not saying that I'm going to go with this idiom, but it's a variation that might be maybe more adapted. Like you can just define if there's an input or not, and if there's no input, you don't do anything with it. But yeah, I think it's a good suggestion. I will consider it.
Great, thanks so much.
My pleasure. Any other questions or comments? Well, thank you all for coming, and I wish you all a good day and a good weekend, and I will see you all in the next live session. Have a good one.